Hi there. Thank you for clicking on this video. The topic today is absolute value inequalities. Please like and subscribe for more math content. Lets me know what content you're finding helpful. Drop a comment below to engage and check out the practice set for this lesson as well as the other videos and playlists on the channel. Now, at the time I'm recording this, we have just started the school year and you might be able to hear it in my voice a little bit. I don't know if the microphone will pick it up, but I'm kind of hoarse from suddenly having to project my voice like all day, every day for hours. So my vocal cords have kind of taken a beating. I apologize for that if it sounds kind of weird. Now, before you start, there's some background information that is really, really helpful when covering absolute value inequalities. So if you need a refresher on how to solve inequalities, like what the symbols mean and how you navigate solving an inequality, please check out the video linked above. That information is going to be assumed in the lessons. I'll put the link up there. You may also want to check out the video on interval notation that is linked in the description box if your teacher requires this and you need to go over it. So there's different ways that you can write your answers for absolute value inequalities, and some teachers might be requiring you to put it in a particular form. So if we get to that part of the lesson, you're like, oh my word, that's what my teacher wants, but I have no idea what it is. I will be sure to link that video in the description box as well. So how do we reason our way through these problems? And I am going to circle this, like it's about reasoning our way through the problems. It is not, well, you'll see, we're going to reason our way through. We are not memorizing a formula or pattern. Now, I don't teach it now, but I have in the past taught dual enrollment classes, which would be past the Algebra 2, Algebra 1 like level. So these are high school students taking college level classes. And so I was not the one to teach them absolute value inequalities. And I would see students come into my class that were like they had been taught a formula, like if you see a problem that looks like this, set up your answer this way. But when asked about like, what does the symbol mean? Why do you set up the problem that way? They really couldn't tell me. And so it was really just a matter of how good were they at memorizing this pattern for doing them and not real understanding. And that's the kind of thing that you will forget. Okay, like the formula or pattern, it's not going to mean a whole lot to you. So we don't want to do it that way. Instead, we're going to be going back to the definition of absolute value. Now, if you need to go back and watch the absolute value equations lesson, I'll try to remember to link that in the description box as well. I'm going to put down like 2 videos. I'm writing a note here just so I can remember to do that. Yeah, so you might want to go back and check that out. But absolute value is the distance from 0 on the number line. That's the definition of what absolute value is. So when you see those absolute value symbols, that's how you want to interpret it in your mind. If you can interpret it that way, then doing an inequality is not super different from doing an equation. Okay, so we're going to look at some really basic examples to start. So the absolute value of x is less than 3. So we want to interpret that, again, using the definition. X has a distance from 0 less than 3. Okay, and we wouldn't normally write that out. Like I'm writing that out because we're presenting the material. But in your head, when you see that expression there or inequality, like the absolute value of x is less than 3. X has a distance from 0, because that's what absolute value means, less than 3. So we're going to engage our picture. Okay, so here's our number line. There's our 0. Here's 3, so that would be 3 units away to the right, and we have 3 units away to the left. Well, a distance from 0 that's less than 3 could be like right here or right here. Like that would all be less than 3 units away from 0, or we could go in the other direction. We want to keep it less than 3 units. So, and it could also be 0. 0 would have a distance from 0 less than 3, but not the 3 itself. Okay, so it's just less than 0. So we would use our open circles on the interval or on the endpoints, and we would be talking about all of those points in between -3 and 3, because those are the points that have a distance from 0 less than 3. So what would be between -3 and 3? Well, that would be x. So you can do this with two inequalities. Okay, so you could say x is greater than -3, and also x is less than 3. So it would have to be both of those things. X has to be greater than -3, and it also has to be less than 3, meaning it has to be bounded on both sides. A better way to write that would be -3 is less than x is less than 3. And you can see those inequalities there. So x is greater than -3. Here it is right there. X is greater than -3, and x is less than 3 is a little bit easier to see because you don't have to switch the order. So that is the preferred way of writing it. This way is not necessarily wrong, although you might need to use an intersection symbol there, and I'm not sure I want to get into that. That involves like understanding what sets are. So we'll just kind of stuck with this, like this is the way you want to do it. Okay. Now, if your teacher requires interval notation, you're going to use the parentheses because it is an open interval, and it would be the interval from -3 to 3. Now, this right here, I will link. That's one of the videos I'll link in the description if you need a refresher on how to go back and do that notation. Okay, so that's a pretty basic one. We're going to look at a couple of additional basic ones. So just kind of getting the feel for like, what do these look like? So the next one is the absolute value of x is less than or equal to 3. And so our interpretation here is x has a distance from 0 less than or equal to 3. So how does that change the problem? So there's the 0, there's the distance from 3, and we've got the distance from 3 in both directions. So it's still less than 3, so it's still all of the ones here, but now it could also be equal to 3. And so what that means is that the -3 and the 3 are now included, because it could be less than 3 or equal to 3, which means that we could have a distance of 3. So those are that. And again, what is in that interval? That would be x. So we could say -3 is less than or equal to x is less than or equal to 3. And if you're using your interval notation, that closed interval where you have the circle shaded in and it's equal to that, so the -3 and 3 are included, we would use the brackets on that. So you can see how that works. You want to remember the parenthesis bracket thing for your notation, and that's what it is to have a distance less than something. Now, next example. So we have the absolute value of x is now greater than 5. So we want to interpret that. X has a distance from 0 greater than 5. That got kind of messy there. Sorry about that. Greater than 5. So let's take a look. So here's 0, here's 5, here's -5. Well, we're looking now for things that have a distance from 0 greater than 5. Well, 6 is further away, 7, 8, 9, 10, 5.5. Okay, so it would be all of these. These are all further away from the 0. Not the 5 though, so we're going to keep an open interval there. And we could do the same thing on the other side over here. So you remember you're sitting at the 0 and you're going to walk a distance, and the distance you walk has to be greater than 5. So 1, 2, 3, 4, 5. As soon as you get to step number 6, you have now walked a distance greater than 5. Not there, because that would be 5, and anything further away. Okay, so again, make sure that like you picture yourself standing at that home base of 0, distance from 0. Are you walking a distance greater than 5? That's going to put you over here or over here. All right, so what's in that interval? Well, that would be x, could be over here, over here. Now, this is a little bit different. This one you actually can't write as a single inequality. You have to write this as two separate ones. So we could say x is less than -5 or x is greater than 5. So it could be either one of those. It's not both at the same time though. So we don't want to say and, because a number isn't less than -5 and also greater than 5. Like I don't know what that number is, but x could be less than -5 or it could be greater than 5. If you were doing this in interval notation, remember you got your negative infinity sitting down there. So this would be negative infinity up to the -5, and then beginning at 5, and here's my infinity down there, going out to infinity. And we would say union, meaning it is both of those like sets together in one big happy set. Like that is our solution set. So that's what the greater thans look like. If you had an equal to, you would color in the circle. You would put the equal to under your inequality or use the bracket in your interval notation. So that's the only thing that would be different. Again, what I've seen students do in the past is try to memorize if I have a less than, then my answer looks like this. If I have a greater than, and they don't go back to the definition. Just remember, like it's distance from 0. So you're at the 0 and you're going to walk from the 0 a particular distance. Is the distance going to be less than something or greater than something? And that will put you on the number line. You can actually see it on the number line. Okay, now this also can get more complicated. So, but it's really not a big deal. So you could see like other stuff in the absolute value or attached to the absolute value. Maybe the absolute value is being multiplied by something, or there's something being added or subtracted. None of that is going to really impact how you do it. You would just solve this very much the same way you would one that like was an equation. So so let's take a look at this. So we've got 2x minus 3 has a distance from 0 greater than or equal to 2. So what does that look like? Here's my number line, here's the 0, here's my distance of 2. So I got a distance from 2 to the left and to the right. And this time we're looking for a distance greater than 2 or greater than or equal to 2. So you start at the 0 and you're walking 1 step, 2 steps. Well, now I've got the equal to 2, so that's going to count. And if I walk 3 steps, that's greater than 2. So 3 steps, 4 steps. So we're dealing with this outside part. Or I could go the other direction. So I'm walking and this is less than 2, like I've walked less than 2. Now right here, now we're dealing with greater than 2 out there. And it could be greater than or equal to. So we're going to include the -2. Now, this time, instead of having an x, what you've got is 2x minus 3. That's the thing that has the distance from 0. That is greater than or equal to 2. And so when you go to set up your inequalities, you would say 2x minus 3 is less than or equal to -2. Or 2x minus 3 is greater than or equal to 2. And then we just solve these. This is why I linked the video to how to solve inequalities, because like now you need to know how to solve an inequality. So we'll add 3 to both sides. So 2x is less than or equal to 1, divide by 2. So x is less than or equal to 1/2. Over here, we'll add 3. So 2x is greater than or equal to 5. Divide by 2, and x is greater than or equal to 5/2. And it's or, okay? So x is less than or equal to 1/2, or it is greater than or equal to 5/2. If you are doing this in interval notation, remember you've got your negative infinity and positive infinity. So I kind of don't have a great spot to write that. I guess I'll write it up here. So it's negative infinity to 1/2. Or, okay, union it with, and then 5/2 to infinity. So that would be your interval notation. Oh, wait a minute, I made a mistake. It's or equal to, so it's a bracket. So we use a bracket, there we go. Fixed. Okay, so I mean, that's how that would work. Now, generally, you won't see anything much more complicated than this. Really, absolute value inequalities are not a super common thing for you to see. So I'll put a few twists into the practice set, but nothing too crazy. So I'll try to like up it a little bit just to give you something to entertain you. But They're not really common problems to see, and so they don't generally get too complicated. They're not the kind of thing that shows up over and over and over again in math. All right, now Desmos can help. So you can use Desmos to graph solutions as a shortcut when needed or when available. This would be great for like an SAT. If you see something like this, you can use Desmos. And here's what it looks like. So here's one. The inequality is -2 times the absolute value of x minus 3 is less than -8. And when you type that in, you're going to get these vertical lines because it's reading it as like y doesn't matter, so it's giving you all the different y values. But what you want to do is just home in on the number line, like what is shaded on the number line. So really what you're looking at with the dashed lines, that's like the open circle, and the shading is going to the left, open circle, shading going to the right. So that's really what you want to look at. And then you can get your answer right off of that. So that looks like x is less than 1 or x is greater than 9. And then again, this, remember, goes down to -infinity, and this goes up to +infinity. So you could say -infinity to 1 unioned with 9 to infinity. Right, here's another example. So this one is 1/2 times the absolute value of x plus 1 is greater than or equal to 2. So notice on that one that you have a solid line instead of a dashed line. So that's the two-dimensional equivalent of that. Okay, so this is another one. Another greater than 1. You might be looking at that top one, and we'll kind of go back and talk about that. So where is this? I wasn't looking too closely. I need to see that number. That's a -6. Okay, so this one is x is less than or equal to -5, or x is greater than or equal to 3. In interval notation, we'd be talking about -infinity to -5 with the bracket, unioned with 3 to infinity. Now, you might be wondering, oh, wait a minute, that's a less than, but it looks like the same kind of graph as a greater than. And the reason for that is that -2 out in front. When you would solve this, you would divide both sides by -2. And when you divide by a negative, you flip the inequality. Again, check out the video on solving inequalities that was linked earlier. And so you have that flip there, which will turn it into a greater than. But this can be like a real big help if it's been a long time since you've solved these and you're like, I just don't remember how to do it. Now, last thing, does this model anything? Well, it does. Now, is this like a really common one where there's like tons of great word problems? No, but it does model stuff. So one common application is something called bilateral tolerance in dimension drawings. I teach engineering, and my intro engineering kids would deal with something like this. So this is a tolerance, and what it's telling you is that that measurement is 1.500 something. Okay, like we don't know what that is. It could be centimeters, inches, feet. We don't know because there's no units on it. The units would be somewhere else on the drawing. Plus or minus 0.0002. Now that's telling you kind of what wiggle room you have. In a perfect world, it would be exactly 1.500. We'll just say centimeters. Okay. But we know that we don't live in a perfect world, that there are variations, even like in a drill bit or like whatever that is that's manufacturing that. So your tolerance tells you how much space you have on either side. So in this case, you could go 1.500 and you could subtract that amount. So that is 8994. Okay, so that's the smallest it could be. And the biggest it could be is 1.50002. So you have what's called like a lower limit and an upper limit. And in this case, it is a bilateral tolerance. And so you could express this as, this is your measurement, And then you could kind of work your way backwards from there, where you like could express it as an absolute value. Now, most of my students don't do it with an absolute value because it seems unnecessarily clunky, but it is the math that models this particular thing. All right, so please don't forget to give this video a thumbs up if you found it helpful, if it clarified some stuff for you. Subscribe to the channel for more math help. Drop a comment or question below and check out the practice set for this lesson, which I will link on this page. And I hope to see you in a future video.